Hello everyone, my name is Daryl. I work as a software developer. In this video, you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient. It'll just be the one that I come up with first as I am working through the problem. So this one is number 104 on the site. We're still doing tree problems. This one is maximum depth of binary tree. So given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node to the farthest leaf node. So here we have this example, and obviously the answer is 3. It's always really odd how this website tries to list the input for these trees, but anyways, output is 3. For this one, they don't give a visual example, but they're saying it's 2. Number of nodes is going to be between 0 and 10,000, and the node value is between -100 and 100. So the value actually doesn't matter at all to this problem. And I left the tree node class here from some of the previous problems that we've used with tree nodes. So this one should actually be pretty easy. And so they do say with the constraints that there can be 0 nodes in the tree, which should return a 0 in that case. So I'm going to go ahead and copy over this. This one's going to be a pretty short one. So first we just need to check if root is null. Return 0. Easy enough. So now we know the root is not 0. Then we can check here if there's only 1. That's kind of another edge case. So if root.left is equal to null, and root.right is equal to null, return 1. Then we're going to go ahead and start our function, or our main function that we're going to use recursively. So private fun, and we're going to say get tree depth, or should I say get max tree depth. And we're just going to take a tree node, and it returns an integer. And it's going to need to take in a current depth, which is an integer. So here we're just going to say max var max depth is going to be equal to 1 at this case, at this point. Then if root.left is not equal to null, max depth is going to be equal to get max tree depth for root.left. We know that's not going to be null. If root.right is not equal to null, max depth is going to be equal to get max tree depth, but we need to pass the number to max depth, and root.right max depth, and we just return max depth. So we're going to say var new max depth is going to be equal to current depth plus 1, because if we got here, we obviously got to the next depth. Then it's basically going to be the same as this. So if tree node.left is not equal to null, then set new max depth is equal to max tree depth, tree node.left, and we pass in the new max depth. And if tree node.right is not equal to null, then new max depth is going to be equal to get max tree depth, tree node.right, new max depth, and then return new max depth. I think that is basically all we need to do. I'm going to go ahead and try that out with the solution, with the example here. Okay, so this one's wrong. My output was 5, and it expected 3. So let me think for a second. So I think the change we need to make is instead of passing max depth to the second one, we want to have a current depth, and that's going to be equal to 1. So you definitely want to be keeping track of this, but when you go here, you want to pass this, and I know it's the same here, but we're just going to pass the current depth. And you can make it a val, that's fine. And I'll do the same thing here. We can just say val current depth is going to be equal to new max depth. And you pass that one in here. And then you also want to check that you're only setting this so this one it's fine to set because it certainly will be farther than this. But this one you want to do that and then say if right max depth is greater than max depth, then max depth is equal to right max depth. And you'll want to do a similar thing here. New current depth. And change this to that. And just do that. Let's try that as a solution. Okay, so that one worked, so let's go ahead and submit. All right, that one worked. So it wasn't nearly as good of a solution as the last problem that I did. Apparently it isn't pretty good on the runtime, it's pretty slow. But it was above average, very slightly on the memory usage. But all in all, it works, and I feel like the logic is not too complicated or anything like that. We could possibly, obviously there's some amount of duplication, and this could possibly be removed and made simpler up here in the original method, but we'll leave it like this for now. Let's go over the code real quick. So here we have our main function. We're checking if root is null, because it can be according to the problem, and if it is, then we're just going to return 0. Then we're going to check if both of the child nodes from root are null. And if they are, then we're going to pass 1. Then we're going to create our max depth, which is going to be what we set to the actual max depth by the end, because we're going to return it. But we do need our current depth, which is just 1, and that's what we're going to pass into these functions later. So then we are going to check if the left node is not null. And if it's not null, then we're going to set the max depth. And it's safe to do that because we know that this is going to be 2. This is going to be greater than this no matter what, so this is safe. And we run our main method, which we'll go over down there, on the left node, and we also pass the current depth, basically so that whatever level we're at, we're aware of what the previous current depth was. Then we check if the right node is not null, but we need to do something slightly different on this side, and this is going to be the same in here, where we get the right max depth, which is the exact same function, just passing the right one, and then we just check, is it greater than the max depth that we ended up getting from the left? And if it is, then we set the max depth to the right max depth. Otherwise, we ignore it, and we just return max depth. Now, this function is very similar to what we just went over, and it's possible this could be removed for reducing some copied code over here, duplicated code. But we're going to create the new max depth, which is current max depth plus 1, because we just got to a new level. Whether or not it's the max depth, we don't know, but we got to the next level regardless. Then we're going to set our new current depth to new max depth, so that we just need this variable because we need this to be the same for this one, and we're changing this one when we run this. So that's why we need that separate one. Then just like up here, we check if the tree node to the left is not null, and if it's not, Then we set the new max depth to that function. And very similar to what we just went over, if the right node is not null, then we do a separate variable, right max depth equals to the result of that function, of this same function. Of course, we're doing recursive calls here. Then we check if it's greater than the new max depth, and if it is, then we set it, and then we just return it back up to here and here. And it ends up returning the max depth. So that's going to be it for this one. Hope that helped you guys out. Thank you for watching. Catch you guys next time.